Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0713, indicates an open circuit in the Continuously Variable Transmission CVT Fluid Temperature Sensor. This sensor is crucial for monitoring the temperature of the fluid within the CVT, which plays a critical role in the operation of the transmission system. An open circuit indicates that the electrical flow is being interrupted, which means the sensor is not able to relay accurate temperature readings back to the Powertrain Control Module, PCM. This can lead to inappropriate transmission fluid management, which could cause overheating or inefficient operation. Understanding the function of the CVT fluid temperature sensor is vital for diagnosing this issue accurately. The sensor is typically located within the transmission assembly, enabling it to measure the fluid temperature as it circulates. This diagnostic information is essential for safe and efficient driving, making it imperative to address this code promptly. The CVT fluid temperature sensor is designed to monitor the temperature of the transmission fluid, ensuring that it remains within a safe operating range. This component plays a vital role in the functioning of the continuously variable transmission, as it helps the PCM adjust the fluid flow for optimal performance. If the transmission fluid is too hot, it can lead to premature wear and tear, significantly affecting both performance and safety. The sensor itself is usually located inside the transmission assembly, making it somewhat challenging to access for manual checks. Any issues detected by this sensor will trigger the DTC P0713, informing the technician of a potential failure in the electrical circuit, as opposed to mechanical issues within the transmission. As this code signifies an open circuit condition, it necessitates a thorough examination of the wiring and connectors involved in this circuit. The DTC P0713 is often caused by various electrical circuit problems rather than mechanical issues within the transmission. One primary cause is a faulty CVT fluid temperature sensor itself, which may not effectively transmit temperature readings to the PCM due to internal failure. Another potential cause is poor electrical connections, which can include corroded, loose, or damaged connectors and wires that interrupt the electrical signal. Additionally, issues such as a malfunctioning wiring harness can lead to an open circuit, triggering this DTC. It is essential to explore these possibilities systematically during the troubleshooting process to pinpoint the exact cause effectively. Understanding these causes can streamline the diagnostic process and facilitate a faster resolution to restore optimal transmission function. Symptoms arising from the DTC P0713 primarily relate to the functioning of the transmission and may include issues such as overheating. When the CVT fluid temperature sensor fails, the PCM cannot make necessary adjustments based on fluid temperature, leading to excessive heat generation within the transmission. This can result in poor shift quality, where the vehicle may have difficulty maintaining power or responding appropriately to throttle input. Drivers may also notice an illuminated check engine light, which notifies them of diagnostic issues within the vehicle. Various performance issues may arise, signaling the need for immediate attention. By recognizing these symptoms, drivers can seek timely diagnostic services to mitigate further damage and ensure safe operation. The first step in troubleshooting the DTC P0713 is to switch the vehicle to on mode without starting the engine. This allows access to the diagnostic functions of the Honda Diagnostic System, HDS. Once in this mode, check the parameters related to the CVT fluid temperature sensor, particularly focusing on the voltage output. If the voltage is above 4.93 volts, it indicates that the failure has been duplicated. Therefore, you should proceed to the next troubleshooting step. However, if the voltage is lower than this threshold, it may signify an intermittent fault. In this case, it's crucial to inspect for any poor connections, loose terminals, or other electrical issues between the sensor and the PCM. If any freeze data or onboard snapshot information exists, try to replicate the failure conditions to gather more diagnostic insight. In the second troubleshooting step, turn the vehicle to the off mode first to ensure safety while working on the electrical components. Next, disconnect the solenoid wire harness 8-pin connector from the engine wire harness side to isolate the sensor circuit from potential interference during the test. A jumper wire should then be connected between Terminal A and Terminal B, where Terminal A refers to engine wire harness side number 3, and Terminal B should be connected to a good body ground. Once this setup is complete, turn the vehicle to the on mode and again check the CVT Fluid Temperature Sensor voltage. If the voltage is less than 0.07 volts, it indicates that the circuit is functioning correctly, allowing you to move to the next step. Failure to meet this criteria will necessitate a deeper investigation into the wiring and connector conditions. For the third troubleshooting step, again, start by turning the vehicle to the off mode to ensure safe handling of the electrical connections. Remove the jumper wire connected previously, and then connect Terminal A and Terminal B using a jumper wire again, where Terminal A corresponds to engine wire harness side number 2 and Terminal B to number 3. Once this connection is established, turn the vehicle to the on mode to conduct a final voltage check on the CVT Fluid Temperature Sensor. If the readings again show less than 0.07 volts, it confirms that the transmission fluid temperature sensor is faulty, necessitating a replacement of the solenoid wire harness for proper functionality. If the voltage readings indicate normal conditions, the sensor is likely functioning correctly, in which case an open circuit in the SG2 wire between the solenoid wire harness and the PCM should be diagnosed and repaired. In the fourth and final troubleshooting step, start by switching the vehicle to the off mode to safely conduct the next tests. Utilize the Honda Diagnostics System, HDS, to jump the SCS line, which allows for further electrical testing. The next action is to disconnect the PCM connector C51P to isolate the PCM from the circuit. You will need to check for continuity between the solenoid wire harness 8P connector number 3 and PCM connector C number 37. This test should confirm that there is a continuous electrical connection in the TATF wire. If continuity is present, it indicates that the wiring is intact, and it may be necessary to update the PCM software or replace the PCM with a known good unit. If you determine a lack of continuity, this signifies an open circuit exists in the TATF wire, requiring prompt repair to restore proper signaling to the PCM. Final repair verification after addressing DTC P0713 is critical to ensure the issue has been resolved. Begin by ensuring all electrical connections and terminals are securely reconnected and free from corrosion or damage. Once all connections are properly secured, retest the system for the specific DTC P0713, again using the HDS. Check for any new fault codes that may have emerged and confirm that the PCM is receiving accurate readings from the CVT Fluid Temperature Sensor. If the DTC does not reappear and the transmission operates smoothly, this is a strong indication that the issue has been successfully addressed. This step helps to ascertain the reliability of the repairs made, ensuring that the vehicle can perform without the risk of future transmission-related problems. Preventive maintenance is essential in avoiding future recurrence of issues like DTC P0713. Regularly inspecting wiring and connectors associated with the CVT Fluid Temperature Sensor can help catch any signs of wear, corrosion, or loosening. Maintaining proper fluid levels within the transmission is equally important. Low levels can lead to overheating, compounding sensor issues. Additionally, employing routine checks of the transmission system alongside adherence to the manufacturer's maintenance schedule will aid in ensuring the components remain in optimal working condition. As these systems age, minor issues can escalate into significant problems if not addressed early. Therefore, preventative efforts can save both time and cost on repairs. Keeping up with these maintenance practices can significantly enhance the longevity and reliability of the vehicle. In summary, addressing DTC P0713 requires a systematic approach focusing on the CVT Fluid Temperature Sensor and its related wiring and connections. Always begin with confirming that the electrical system is operating within the specified voltage thresholds. If faults are detected, rigorous troubleshooting steps allow for pinpointing the exact cause, whether it's a faulty component or an open circuit. The process of verification ensures that all repairs are completed successfully and that the system will function correctly. Additionally, ongoing preventive maintenance is crucial for sustaining the longevity and performance of the vehicle, which involves regular checks and timely replacement of worn components. Following these guidelines will not only rectify current issues, but also preempt potential future complications. Please like and subscribe to the channel. See you next time.